Hello. In this video, we'll be talking about the various types of attributes a data point can have. We have seen earlier that measuring similarity between data points or data objects is important because we would want to know how similar two data points are to each other. And for this, proximity measures would be required to make deductions like assigning labels, predicting values, or to form groups or clusters. So before finding the similarity or discussing the similarity measures, we would want to go into some details of the attribute types which a data point can be comprised of. A data point represents an entity and it is described by attributes or variables. These two terms are interchangeably used in our videos as well as in literature in most of the places. So the different attribute types are nominal, binary, and ordinal, these being the qualitative types and the numeric, which are quantitative. As we might be aware that a data representation would need both quantitative types and qualitative measurements. So we would be discussing these two types. So first, the nominal attributes. So the nominal attributes are basically comprised of names, those attributes which are comprised of names of things and also often called categorical attributes. For example, elective courses. So possible values could be unsupervised learning, deep learning, reinforcement learning, network analysis, and similarly marital status. Another example of nominal attribute, the possible values could be married, unmarried, widowed, or divorced. Now we could possibly also represent these names with numbers, right? So you could use 0 for unsupervised learning, 1 for deep learning, 2 for reinforcement learning, 3 for network analysis. Very fair, you could do this. And similarly for marital status, you could assign 0, 1, 2, 3 numbers for these names. But we must realize that these numbers are not to be used in a quantitative manner. Like you could not add or subtract these numbers. Even finding the mean would be meaningless. So most of the mathematical operations would be meaningless on even if you represent the nominal attributes using numbers. However, you could use the mode, which is the most frequently occurring value. So that would definitely make sense even for the nominal attributes or the names, whether you're representing as numbers or as names. Now we come to the binary variables. A binary attribute is a nominal attribute with only two categories, which you could assign numbers 0, 1, or you could have two names. The attribute pneumonia, you could represent 1 for patient that has pneumonia and 0 for a patient who does not have pneumonia. Similarly, faulty for a software module object. 1 would mean the module is faulty and 0 would indicate the module is not faulty. So binary variables having two categories represented by 0 or 1. Now, binary attributes having two categories can also fall under symmetric or asymmetric. Now, we would want to know what is symmetric. We call it symmetric when both its states are equally important and carry the same weight. For example, the attribute gender. So two states, male and female, you could assign 0 or 1 to either of them. However, in some cases, outcomes of the states are of different importance. For example, if you are trying to find whether a software is faulty or not, then you are assigning importance to the state where it has fault or the positive state. And the negative state is one which holds lesser importance in your study. So in these cases, you will usually assign a 1 for for the more important state and 0 for the less important one. And similarly, when we go on for our similarity computations, we'll see the difference between these two states. We would have different measures. So in case of asymmetric, we code the important outcome as 1 and the other one as 0. Ordinal uh, attributes. An ordinal attribute has an ordering or ranking among the names. However, magnitude between the successive values, like what is, you cannot compute a difference between the adjacent names, like level of satisfaction could be assigned the values very less, average, good, and high, and we could easily realize that there is a kind of ranking, increasing order of satisfaction from very less to high. However, difference between very less to average cannot be computed. Similarly, average to good or good to high. Another example being severity of disease. In a study, you would want to categorize the severity of disease as low, medium, high, and risky. So obviously, risky is very high severity. Now, ordinal attributes sometimes come up when we are discretizing numeric quantities, maybe for more understandability, maybe for making the study more compact. So, as an example, you have age attribute and you have the age values starting from, say, 18 to 65 in a study. So you could categorize 18 to 30 or 18 to 25 as young, 25 to 45 as middle age, and 45 above as senior. Or you could create 4 categories even. So that is also again how you get ordinal attributes, because you have the categorization as young, medium age, and senior age. So that is another way ordinal attributes come up. So here in ordinal attributes, mode and median can be used, but the mean cannot be defined. So we saw that all these attributes which we have discussed, nominal, binary, and ordinal, are qualitative. They describe a feature of an object without giving an actual size or quantitative. So we are not getting any idea of quantitative value. So the qualitative categories we are seeing. And even if we use integers, they are more like codes for the categories rather than measurable quantities. For example, juice size can be named as 0 for small, 1 for medium, and 2 for large. Next, we go in for the numeric attributes, interval scaled variables. As we said, variables or attributes. These are numeric and measured on scale of equal sized units. Positive values 0 and negative values are there in the interval scale. For example, temperature. So you can talk about a difference between the values. Like when you say 33 degrees centigrade, you are meaning correct if you say it is 5 degrees more than 25 degrees. So in interval scale variables, you can talk about a difference between two values. Mean can also be computed in addition to median and mode. See, now we are talking about numeric or the quantitative attributes. So mean, median, mode can all be computed. But temperatures in Celsius or Fahrenheit do not have a true zero, so ratios cannot be talked about. Okay, like 20 degrees centigrade is twice as hot as 10 degrees centigrade. You cannot measure it in that manner. A ratio scale variable. Ratio scaled attribute is a numeric attribute with a true 0 point. Like any count attributes are ratio scaled because 0 would mean 0 count. Like number of errors in the object software modules. If you are studying software modules and you have number of errors as an attribute or a variable, then 0 would mean there are no errors, and 1, 2, or 3 would mean that many number of errors. So these are ratio scaled. It is a numeric attribute with a 0 point. The values are ordered and we can compute the difference, the mean, mode, median. Again, we are talking about numeric attributes. Further, you could also categorize attributes as discrete versus continuous. Attributes like elective courses offered or marital status or pneumonia, which we have seen in this video, are having finite number of values and are discrete. If the attribute is not discrete, it is continuous. We'll discuss these in more details in our future videos as we talk about the proximity measures and the examples for the different types of attributes discussed in this video. So thank you. Thanks for watching.